All right, on 5-7, I'm making some adaptations really quick. I'm changing the formulas to 1 through 5. So when I go back and ask which formula, it'll be easier to tell me which one it is. So these are all application problems. And we're going to talk about interest. Interest can be good or bad. So I'm not really going to write anything down, but interest is, for example, like if you get a loan to buy a car, not only do you pay back the amount of money that you borrowed, but you have to pay back extra money because they charge you for borrowing their money. So in the long run, you're paying back more money than you borrowed. There's also good interest, like when you open up a savings account, you put your money in there, but then they give you an interest rate to have your money grow because they're paying you to use their institution to save your money in. Okay, so the first formula is compounded annually. So I'm going to write down the formula, and then I'm going to write down what the variables are. Okay, so that is what you use when it's compounded annually and it's growth or appreciation. Depreciation is the same, except instead of having 1 plus r, you're going to have 1 minus r. So far, let's write down what some of these variables mean. A is going to be the ending amount. P is going to be the principal amount, which is also the starting amount. R is the interest rate. And T is the time, usually in years. Okay, so that's what we have so far. Okay, the next one is compounded either quarterly, monthly, daily, etc. So I'm going to add to this first formula here. So everything stays the same, except you're going to divide the r by an n and multiply the n by the t. So n represents the number of times per year. Okay, now if it says compounded continuously, you're going to use something called PERT. So A again is the ending amount, P is the starting amount, E is just a number that we talked about, R is the rate, and T is the time. And then half-life, you're actually going to use 2 formulas. The first one is PERT, and then you're going to use either this one, that's an H, or you're going to use this one. So you're going to use this one definitely, and then one of these. And H stands for the half-life. Okay, if you have a population problem, population is continuous. So if you had a population question, you would use formula number 4. Okay, so let's go ahead and begin. You're definitely going to need your calculator. So in number 8, it says compounded annually. It doesn't say anything about your money depreciating. It says that they're paying, this account pays you 8.5% interest. So you have to figure out how much you're going to have at the end of 4 years. So we have to find our ending amount. Our starting amount is 900. 1 plus the rate, you got to change it to a decimal, so it's 0.085, and then the time is 4. Okay, so since the variable is by itself, all you have to do is put that in your calculator and then figure out what the answer is. And you can put it in just like you see it. Okay, and I got $1,247.27, which makes sense because we should have more after 4 years if we are earning interest. So 900 was what we started with, that's what we ended with. Okay, number 9 is compounded quarterly, so we're going to use this formula right here. So we're not really sure the ending amount. The starting amount is 3,500. 1 plus, the interest rate is going to be 5.4%, but I want to change that to a decimal. So 0.054, 2 decimal places to the left. And then N, that's how many times per year. So since it says quarterly, that's 4 times per year. And then it's a 5-year certificate of deposit. That's what that means. That doesn't really mean like a CD is what you play music on. It's a certificate of deposit. It's like a savings account. So T times N, again, N is 4 for quarterly. Now this one you have to be careful how you put this in your calculator. What I would suggest doing first is maybe figuring out what this is. So 0.054 divided by 4. And then I'm just going to put a 1 in front of it. And the exponent is 20. Okay, so once you condense it a little bit, now you can put all that in your calculator. And again, you are earning money off of this certificate of deposit. So after 5 years, $4,576.60. Okay, moving on. Okay, let's see if I can skip some of these. I think they're all different, so I don't think I can. Okay, so we are going to do, this one says compounded annually. So I'm going to use the first equation, which was this one. This time it gives us the ending amount. That's how much we're going to have at the end. It says how much must you deposit, so we don't know the starting amount. The interest rate as a decimal is 0.0725, and then 3 years. Okay, this time the variable is not by itself, so we're going to have to do some working backwards. So what I'm going to do first is this becomes 1.0725, and then I'm going to figure out what that is. Okay, 1.0725 to the third power. Okay. So 1.2336. I knew there was more. I don't really want to round on this one because if you round it doesn't keep your answer as exact. So I'm just going to say in order to get P by itself I just have to divide this over. So I'm going to take 1700 and I'm going to divide it by that answer that we just got. So maybe I should just, I don't know what to say there. Okay, so this is the answer to this. Okay, so my starting amount was $1,378.02. That is my answer. So you can write down what you get, but when you put it in your calculator, you kind of want the entire number. That's why I called it answer, because when you put this in your calculator, which is what you wrote down, you want to keep it exact. You're going to do 1700 divided by whatever that previous answer was in your calculator. Okay, number 11. This one says compounded continuously. So if it says continuously, we're going to use PERT. I don't know what the ending amount is. I don't know what the beginning amount is. All I know is that my years are 10, and then something's going to triple. So this is where you can start with any amount of money, and you're going to end up with the same answer. So let's say I start with $1. If I triple that, I end up with $3. Okay, E, R, we don't know what the rate is, but the time is 10. Okay, the first thing you want to do is divide this over, which is 3. So even if you started with $3 and you end up with $9, if you divide these two numbers, you're always going to end up with 3. So if it says triple, then you can just say 3 equals, ignore the P. If it says double, 2 equals, forget about the P. Okay, now from here, my variable is in the exponent. So if you recall from 5-6, if my variable is in the exponent, I have to put a natural log on both sides. Because what that does, that allows my exponent to drop down to the front, and I just switched my R and my 10 around. And then the natural log of E, that can just cancel because that's just 1. So then I'm going to divide by 10. So now you're going to put this in your calculator. The natural log of 3 divided by 10 will give you about 0.1098. I'm looking for an interest rate. So that's the decimal. If I want the percent, now I move it to the right 2 places. So 10.98% would be the answer. Okay, moving on. This one says compounded annually, so I'm going to use the first one. All I know are the number of years, and this time it says double. So you're going to put 2 equals 1 plus R, I don't know what the R is, but the time is 8. Okay, now this time I do not do the natural log. I only do the natural log on both sides if my exponent is a variable, which it's not. So in order to solve for R, I have to get rid of my 8. To do that, I do the reciprocal. So 2 to the 1/8 equals 1 plus R. And then the last thing I want to do is subtract 1 from that. Let's put that in our calculator. Make sure 1/8 is in parentheses. Okay, so the rate is 0.0905. I want a percent though, so I got to move it over 2 places to the right, and I get 9.05%. So that's my answer to that one. Okay, 13. This time I see decreases. If I see the word decreases, then I'm using the second formula, which is this one. All right, I do not know the ending amount. The starting amount is 15,000. The rate is 8%. Got to move that to a decimal, so 2 places to the left is 0.08, and the time is 5. The variable is already by itself, so all you have to do is type that right into your calculator as you see it, and you should get $9,886.22. Now this time it's depreciation, so that makes sense that your amount is smaller than what you started with. So this answer does make sense. Okay, moving on to our last page. All right, this one is a population question. So I'm going to use PERT because population, like I said at the beginning, is continuous. Okay, so my ending amount is 20 million. My starting amount is 13.6 million. And I don't have to write down all the zeros. I can just put the numbers in like I did it. E is just E. The rate is 3.4%, but as a decimal that's 0.034. And then we're trying to figure out when. So I do not know what the time is. Okay, since my variable is in the exponent, I eventually have to do the natural log of both sides. But before I do that, I have to make sure the base and the exponent are by themselves. So I'm going to divide this over. And since I got a decimal on my calculator, I'm just going to leave it like that for now because I want to keep my answer exact. Okay, from here, the only thing I can do now is drop this down in front. But I only can do that if I put the natural log on both sides. I'm going to drop my exponent down in front. All right, so this right here is 1, so I can just cross that off. And then to get t by itself, I just divide this over. So I'm going to put this in my calculator first, and then I'm going to divide whatever I get by 0.034. Okay, the natural log of 20 divided by 13.6 is that, and then I'm going to divide that by 0.034. So I get about 11.343. Now I have to make sure I answer the question. It says, when will it reach 20 million? Well, I could say 11 years, but the reason they gave you the actual year is probably important. So 1986, 11 years later, would be 1997. So that's going to be my answer. Okay, the last two have to do with half-life, because I see the word half-life. So whenever it says half-life, I need to make sure that I use two formulas. The first one's PERT, and the second one is either R equals or H equals. Since I know what the half-life is, then it's going to be R equals, because I don't know what it is. All right, so this radium-226, this 226 is not going to go in your formula. That's just the chemical we're talking about. I know the half-life is 1620, so I'm going to put 1620 in for H. Okay, I'm going to go ahead and figure out what that is in my calculator. So negative natural log 2 divided by 1620. Okay, I'm going to have to store that because this is a really weird number. That just means it's going to be really close to 0. So I'm going to store that for x. So to store it, I'm going to go to the store button, which is right above on. Right here, I'm going to hit store. Push that. I'm going to store the answer that I just got in for x. So just hit the X button, which again is right there. Hit enter. Now you stored that in there. Okay, let's come back to this equation now. So the ending amount, we don't know what that is. The beginning amount is 4. E is just E. The rate is what we just stored in our calculator. So I'm going to call that X now, but X is really a number. And then T is 500. All right. So in my calculator, I'm going to do 4 times e to the power of, and I'm going to do 500 times x. 3.229. 3.229 is my ending amount, and I'm going to call it grams. Make sure you always label your answers. All right, finally, here's another half-life question. So we're going to use PERT. And let's see, I do know what the half-life is. So I'm going to use R equals again. Okay, it says the half-life is 16. I'm going to put 16 in for there. Okay, let's put that in our calculator and see what we get. Okay, we get that right there. So I don't want to write that down. I don't want to round it. I want to keep it as exact as possible. So I'm going to store that for x. So store that for x. Okay, now it's stored. So now this number is x. So it's exactly the number that I should have. Okay, now I'm going to come over here. This time I want to know how many days. I'm trying to solve for t in this problem. My ending amount was 20. My initial amount was 240. E is just a number. Rate is x, stored in our calculator. And then I don't know what t is. Okay, the variable that I'm trying to solve for is in the exponent. So I got to get all this by itself first. So to do that, I'm going to divide over the 240. All right, so again, since my variable is in the exponent, I got to do the natural log of both sides. My exponent drops down to the front. Okay, this is just 1. So I can just cross that off. So to get t by itself, I'm going to put all this on my calculator and then divide the x over. Remember, x is stored in our calculator. Okay, let's see what we get. Natural log of 20 divided by 240, and then divided by x. You should get 57.359, and it's time, and this time it's days, not years, because it says so right there. So that is my answer.